we have to do pre-order tree traversal, and it should be done using iterative method instead of recursion. So how to approach it? Okay, so one thing is that let's try to first review what is pre-order tree traversal. Okay, so that will help us. So we write pre-order, so void pre-order, and then we have struct node star node, and then what we do, if node is not null, so then what we do, so if node is not null, so I first print the data itself, so print node data, and then I do what? I do pre-order node left, and then finally pre-order node right. Okay, so this is my recursive method, and if we see for a small example to know what is this pre-order traversal, so let's have a tree 30, 50, 10, 5, 20, 40 and 60. So if we perform the tree traversal of this particular tree, so we come here, we call pre-order root, and root is not null, so what we do, we print 30, then we do pre-order node left, we come here, again we print 10, we do pre-order node left, and we come to this node, we print the data, we do pre-order node left, which is null here, so it comes back here, and then it does pre-order node right, which is null again, it comes back to this place, and we have already done the printing. Pre-order node left has been done, so we do pre-order node right. Now 20 is printed, its left and right are both null, so it comes back again here and it goes to 10. For node 10, printing of the value pre-order node left, pre-order node right is done, so we go back to node 30, and then we have already done till pre-order node left, so we start pre-order node right. We come to node 50, we print that, we now go to pre-order node left, we print 40, we come back again here after these two nulls, we go to 50 and then to 60, so this way we complete, and these two are null, it comes back here and it comes back here. So this is what is printed: 30, 10, 5, then 20, then 50, then 40 and then 60. So this is called the pre-order traversal, and now we don't have to use recursion and we have to do the same thing. So what should be the approach? So as we see here, so what happens is that we see that whenever we use recursion, so we are using recursion, and if we are asked something iterative, so we have to use data structure called stack. So what should be done? So let's start with one of the simplest, like if we have a simple 3-node tree, so what should be done? So let's start with very basic, and I have to use stack. So what will I do? So I know that okay, in this tree first 30 will be printed, then 10 will be printed, and then we should print the 40. So what should be done? Let's try out with stack. So we have a stack here, and if we push 30, so I know that okay, if we push 30 it should be printed first, So I now pop it out also and print 30, but I push the right child, which is 40, and then the left child 10. So why I pushed right child first? Here if we see, so the node is pre-order node left is being done first, but here you see that I tried to put 40 the node right first. That's because we are using data structure stack, and whatever is pushed afterwards, last in, it is first out. So that's why I put left child afterwards last, and it comes out first. So now I pop 10, so it comes here, this is gone, and now I have pop 40. So this is correct. So I'm finding that okay, so pre-order is working fine with this kind of stack. Let's try to now increase the complexity a little bit. So let's have it 5 and then a 20 here, and a 35 and 50. So now let's do the operation to bit bigger problem. So I again push 30 into the stack. Let's have a current pointer. I make it current is equal to stack dot top. So I have 30 here. I pop it out and push the right child and the left child. So now I have printed 30. So now what happens? Again I do the iteration and I pop out 30 from here. I make current is equal to 10 and I pop this out. So I pop 10 out, and then what I do? So 10 will be printed here, and I push its right child and then the left child. So let's see what is happening now. So I have again this one. So now I pop this one out and print it, and it's right and left child is null, so I don't push anything on the stack. So next that comes out is 20. 20 gets printed here, its left and right child are null, so I don't push anything on the stack. So what happens is now I am left with 40. So I make current is equal to 40 and I pop that out, print it, but I push its right and then its left child. Okay, so now what happens? I pop the top, which is 35, its left and right are null, so I don't push anything. Then I pop 50 out, and it's nothing, I push nothing because both its left and right child are null. So everything is now popped out and there is nothing to be pushed. And if we see, so this is printing the pre-order beautifully. So pre-order is getting printed here. So we just check 30 is printed, then we come here 10, then 5 is printed, then it goes back to the right child, so 20 is printed, then it comes here and goes to the right child, so 40 is printed, then 35, then 50. So this is perfectly fine. So this is correct, and that's how we get the idea that okay, our pre-order algorithm is working. And now only thing is that we have to write the code, and data structures that we use is stack, where we push elements, first the right child then the left child, and this is basically when we were pushing, so it is kind of queue. So we were popping the elements out and pushing them in and queuing them in a queue, or you can directly print it. If you queue them, so it will become basically you have stored them. So now let's try to see the code. So this is the code here, void pre-order iterative, and we put the binary tree root. So what happens is, so we have if root is null, so there should be nothing printed, I just return. Now I make if root is not null, so I make a stack of binary trees S and a queue where I will store all the output. So first thing I do is I push the root to it, kind of initialization. So while stack is not empty, so that's what we were checking here. While stack is not empty, so we were doing some operation. And what is that? So I find the current pointer, I make a binary t star current, which is equal to s dot top. So here I'm not popping out, but I'm only finding the top element here. I'm enqueuing it into the queue, or otherwise I'm printing it, because this is the, whenever I get element I enqueue it or print it. So in pre-order, as we see, so first we print the node data. So that's why I'm doing here what I'm doing here. Then I do s dot pop, but I've already stored that element here. Now if the current write is not null, so I push the right child first to the stack, and then if the current left is also not null, so I push it onto the stack. And again here I push the right child before the left child, because I want to process the left child first. So this I keep doing, and until when? So until the stack is empty. So this is, if we try out with a small case, let's take 40, 20, 60 and 10 and 30 here. So let's try this code here just to make you understand it better. So what happens, I do pre-order route I pass, so this is the route. So now what happens, so there is a stack, okay, and there is a queue. So this is a queue, this is a stack. So this is basically output. So what I do is I push the route here, and then what I do, while stack is not empty, so I make current is equal to s dot top. So current is equal to s dot top. I enqueue this here, and then what I do s dot pop. So it comes out, and if the current write is not null, so which is not null here, I push it here, and if current left is not null, I also push this here. So what, now again I go here, while loop, s is not empty, so s dot top is equal to current. So current is now 20. So what happens, I enqueue 20 here and then pop it out, and 20 has left and right child, so I push the right child first and then the left child. So this happens, and now what happens is, again if stack is empty, no, so s dot top, so current is now 10 and it is popped out. It has no left and right child, so nothing is pushed onto the stack, but again stack is not empty, so I iterate, and then current is s dot top, which is 30 here. So now what happens, 30 is pushed, and then so 30 is pushed, enqueued in the queue, and then it is popped out here, and its right and left child are null, so nothing is pushed onto the stack. We now again iterate and see if the stack is empty. No, it has element 60, so I current is now equal to 60, and what happens, I enqueue it here and I pop that out. Its left and right child are null, so now I again go back. Now so this 60 is here, and now the stack is empty, so it means I have covered all the tree. So we have the queue now, and this is the front, this is the back, and while the queue is not empty, I print all of these, so 40 will come out. So basically now I'm printing, so it will be 40, 20, 10, 30 and 60. So which is correct, 40, then 20, then 10, then we come back to 30 and then 60. So this is about pre-order traversal of binary tree using stack, or basically using iterative method.